How you doing, everybody? Randy Richard in the shop. Well, we're up to the parts of making the brooches for the Hemingway Kit compact rotary brooch. So I think this is video number 5. We're going to use a piece of silver steel that came with the kit. Also in here at US, it's commonly known as drill rod. The stuff is 8 millimeters in diameter. And here's the part, they show you 3 here that they've made: a large hex, a small hex, and a square. Here's the details. They have some detail drawings right here. So here's the brooch detail. And what they've done is they've told you the pilot hole equals, when you're going to make the brooch at least, the pilot hole depth is 1 1/4 times the brooch depth of how long you've made your brooch. The brooch depth is 1 1/2 times the minor diameter, and that's they say is the maximum minor diameter. What else here they have on here? They show you here, the minor diameter as required, and cut over size, say 1/10 of a millimeter to allow for sharpening. The outer diameter of the rod is 8 millimeters. And what they've done is they've done a little chamfer detail on the end to make it so it slips in easily, and a little chamfer on this end, and then this is the broaching part here. And they have down here 2.5 degree angle on the sides of the brooch for clearance, and a little flat here, a little Weldon flat type setup for the set screw. Hardened, then sharpened by hand with slipstone or diamond file. And then, like I said, this is the whole preparation here. Pilot hole diameter equals minor diameter plus 1%. So that's the pilot hole diameter you're supposed to drill. 90 degree countersink diameter equals brooch major diameter. So you should countersink it before you broach it. That would make broaching a little easier, and it make for a nice clean hole. So we got a piece of stock. We got how much? We've got 150 millimeter, 145 millimeters worth of stock. 5 and 11/16 in length, inches. So that should be enough. We need 1.102 inches or 28 millimeters in length. So that's not too much. That's 1.1. So we have, let's just figure 1 1/8 right off the bat. So you got enough for 2, 3, a good 4 or 5 brooches actually there. So we'll figure out making some small hex brooch, I think. Let's start with that one. And I'll figure up a size to fit some small bolt or something that would work in. So we'll see what I have for that. Alright, I'm all set up here with the indexer, the 5C call it indexer. Now I just have it squared up on the table. I use the back side to square it to the table. I'm using a 1/2 inch end mill and a end mill holder, so I have clearance here. I knocked the head of the milling machine over this way to 2.5 degrees, and I've come in 5.5 millimeters on the end, and come down, and we're going to touch. And then we can index it around, touch to the other side, and we can fine tune that again to the right end diameter, which is 4.8 millimeters. And hopefully we'll come out with a nice even hex on there. 4.813. 4.815. 4.814. We're calling that perfect. So there we go. Oh, here, we'll darken that end again. Don't worry, we'll show the bloopers. This is not easy to do. Now we're going to take it to the lathe and chamfer this little edge real quick. Okay, I've heat treated it. We'll just see how that goes. But it's nice and sharp. I did buff it a little bit with oil stone. And we're going to get some final measurements here to see how we did. Now this will be millimeters. 4.791, 4.795, and 4.790. So not too bad. We were shooting for 4.8. I'm good with this. And we're going to have to give this a try. Here's all the parts. You got the screws for the shank, the body, spindle, the locking ring, and the broach, and your thrust bearing, your two radial bearings. I think that's all the parts. Now I'm going to assemble it. So you have one thrust bearing piece here that fits tight on the shaft, or fits well, I should say. You know, it's not loose like. So this one here is the one, and this one is the one that's kind of loose and a little sloppier. So we're going to put that one on there. Then the bearing itself. And then the bore one goes on. Then the little end bearing goes on. Just like that. Now, I'm going to put a drop of oil. I'll put a small drop of oil on that thrust bearing. There's a couple drops. So it has something in there. Now we have access through the hole in the side for the. We might have to do this in stages. There's a lot of stuff to put together here. I'm just going to drop that in there. Okay, that's in. And I'm going to drop that race down in there. Get that seated. And we'll put the spindle in. All the parts here, they gotta fit together. I know they fit. I put a set together several times, but just you gotta fiddle with it a little bit. I'm wearing John Mills t-shirt here today, so I think that's kind of classic. A British project, wearing somebody from Britain's t-shirt. That's pretty cool. I hope John can make it to the bash this year. Heck, I hope I make it to the bash this year. Come on. You know what? Maybe that set screw. Oh yeah, that set screw is sticking out a little tiny bit too much. There we go. There we go. That's. I think that's going to go in there fine there. I think. So we got. It's not. There we go. Oh yeah. And if you can see there, there's the set screw actually lines up just perfect. That came out just really nice. The radial bearing goes there. And the locking ring goes on. Now you gotta make sure it's the right way. The counter bore side goes down on the bearing. And my fancy face spanner here. This is adjustable face spanner, so you can tell. Yeah, oh, that feels good. Very smooth. Very smooth. Yeah, so that's just kind of snug. But spins, and I feel no play whatsoever in that. Well, the shank goes on there, like so. Sits on a little key and in the slot. Two little these little 3mm socket head cap screws go in. We're just going to leave those loose because there's some type of an alignment procedure you got to go through. So we'll just leave those a little bit loose so we can move this around. Then the broach goes in. That set screw lined up. Got back out a little bit. Okay, I'm on the flat, and we can tighten that up. Okay. There's the assembled unit. Broach in there. So this is how big it is. It just barely doesn't even quite reach across my hand. So it's not a very big piece of equipment. So we're going to go through the rest of the procedure here now. I've already pre-drilled this. I pre-drilled the piece of brass. I didn't film it. It was only drilling 2 holes, a number 31 drill and a number 11 drill. The number 11 drill is the pilot size hole for the size broach I had calculated, and I drove it a little over a quarter. I drilled it a little over a quarter of an inch deep. Now we have the broach in here as assembled, and this is loose still. See that on the shank. And their alignment procedure is you bring this up, and being loose, you can feel it align with the hole. Now I set it up so it slides back and forth 90 degrees, and it's staying flat against the shank. Now this is important, I guess, because you're going to tighten it and you want it to be flat. And I just kind of wiggling it there, and aligning and pushing it in slightly, and it aligns nicely, and it's staying flat. I can't see any gaps. Now I need to tighten those screws, which is a bear. So I think what I'll do is I'm going to extend it a little more, and so I can get the Allen wrench in. I extended this a little bit more so I can get the Allen wrench in there. And this is still nice and loose, and we're going to slide it gently up to our hole. Now they say to turn the lathe slowly so you can feel it cut, but I got a real good feel for where that's at, that it's centered up, because I did countersink the hole a little bit. I'm going to tighten these, snug these up. Now they suggest putting washers on these set screws. I don't have any small enough to go in there. So I'm going to take this out and tighten these up good. Alright, those are pretty tight. Now I'm gonna suck it back in here. And that should be it. Still centered with the hole. That says it's time to broach a few holes. I will put it on a little bit slow speed, and let's just see how this works. Going in easily, just cranking it right in. Did you see how it was spinning freely? I just used a little piece of brass. I don't know if you can tell, but bring that up, and it's definitely a hex hole. Now we'll get our little screw to test it in there. I went and grabbed my little screw. Now I just had to pick out a couple of the chips that pushed down and were over the hole so I could slip my piece in there, but this, there we go. Does it fit? Oh, wow, that fits perfect. I'm not kidding. Just the very slightest, you can feel a little bit of movement, so it slips in real nice. Wow, that's a definite success. Very, very cool. Now if I slip this around, I'll have to have something to probably poke it. Well, maybe not. Anyway, that went right in. I should have went deeper, I guess, but see if I can get it out. There we go. Of course, whenever you do it on the lathe, you drop it in a bunch of chips that you haven't cleaned out. Which I really need to clean this lathe up. But anyway, that worked absolutely wonderful. Well, to Hemingway Kits, the Rotary Broach is a great success. Works very well. it's not very big, but why couldn't you make a bigger one, right? It'd be easy to make a bigger one so you could do maybe, you know, 1/2 inch or something, you know, right? And I know there's ones out there you can buy. But you definitely could follow the same design and design your own to be able to do bigger stuff. But anyway, this little for little stuff, making little holes, it sure works perfect. They're just a little fiddly, of course, as Chris would always say. The tolerances, you have to maintain close tolerance because it's a small piece of equipment, small thing, so your tolerances are small. This came out beautiful, and it works grand. Now you can take this now and turn this down. Yeah, I'll probably put Loctite on those screws first, but you can turn this down then to make this a nice smooth diameter, so you don't have to feel that offset between the shank and the body. So this is a great success. Thanks, you guys. Thanks for watching. And I'll have to make some more brooches, maybe stuff for square stuff, something common size, or for Allen keys, things like that. I just had picked this, and I probably should have just made one for an Allen key, but I'll have to make some more brooches so I could actually do Allen headed stuff. So thank you guys again. Thanks for watching. Thanks for Hemingway Kits for the kit. Well, the final step here is to turn this all to the same diameter with the offset. What I did is I dialed it in here with, this is a Just True buck chuck. I dialed this in here to within a few tenths. And we're just going to turn that all down to one diameter. There we go, all turned down. That looks, I mean, it's all concentric on the outside, yet it has a 1 degree offset to give you that wobble, and that wobble is called nutating. If you've ever looked into a nutating disc, especially fluid meters, you can look into those, and some pump drives for hydraulic pumps have a nutating disc. And that's the action that's going on here. So anyway, this is finally really done. Very nice. So a little recap. This is all the material I had left over. About an inch worth of 1 inch, and another 3/4 of an inch, 1 inch material. I don't think there was anything else left. So that's it. And I have a couple inches, 2.5 inches of 8mm drill rod or silver steel. We all figure this is, with comments and everything on the material, that this is probably 12L14. The way it cuts, I would say it's awfully soft, and that's probably what it is. So here's the finished product of our efforts, a little hex and that little piece of brass, and a beautiful little fit. So I'm gonna have to make some that was for Allen keys, I think, so I could do some my own Allen head screws or bolts. And this is the finished product right there. Came out really good. Very happy with that, and it seems to work quite well. And then so we had two screw ups in making the first broach. We tell you, I had a heck of a time getting the hex right. I had to do a complete disassembly and cleaning and reassembly of my 5C indexer. It was just dirty, and the locking pin was not engaging far enough, so I had some play, and with just a cleaning and reorientation, and it came out perfect and worked extremely well. So my other methods did not work, and that's what happens when you're doing something small like this. Sometimes it might take a few tries to get it just right. So this one came out just great and perfect, and all heat treated. So some of the tools that I used in making the rotary broach, I had quite a few comments and questions about my parting tools. This one I've had for a little bit. Here's the number. This is made by Shars. So it's a holder with a blade. Now, it works okay. It's all, I mean, I've had my failures with it. It's probably not stiff enough. I think I'll be eventually picking up a different blade one, maybe by Iskar, but I'll pick up a different one that stiffer, that could maybe part up to 2 inches type of thing, be a little taller. So that's my thoughts on this. It's okay. It does work, but I've had a few get ripped out of there and things like that. This is the other one I have. So this one I received, it's actually a left-handed one. I want to get a right-handed one like this, if I can someday afford one, but that's what I'd like to get. This one's by Seco. This one I received from Dennis Nolan with all the other tooling that Seco, Niagara Seco supplied. This thing is awesome here. It's stout. It's very narrow. It took a little bit. I don't think they make this one anymore. You can still get inserts for it, but I don't know if they make this one anymore. From what my research was, it's an older model, but it is awesome. It takes this insert's about an inch long, two ends to it, and they're kind of pricey, like $25 a piece, pricey. But boy, does it work good. I can't remember the thickness on this one, but so here's the number on there, just so you guys can see that. But it does work awesome. It is rigid. Now you do have a limited depth, of course, so I don't think you can quite do. You might be able to do 2 inch diameter on this one. It's pretty close to it, but it does work awesome. You just gotta remember a few simple rules about parting. Be on center or a skosh above, never below center line. Watch Joe Pye. He just did or I don't know if he just did it, but he just did it. I think a video on parting and parting tools and grinds for high-speed steel ones or even carbide ones that you have. These ones are insert ones. I also have high-speed steel ones. I really like this one here. I really like using. This one works well too, though. But you do have to be straight, perpendicular to your work. And don't be afraid to feed it. You gotta remember, every time one revolution, you cut off one thickness. Well, if you don't keep feeding it, you won't stay in the cut. If you pause, you're out of the cut immediately as it comes around in one revolution. So you got to keep feeding. If you go too slow, you can have problems, chatters, and things like that because you're getting out of the cut. So it takes practice, and stay in the cut and get on center. If you have to push too hard, you're usually not on center, or if you see any deflection. Now, the other thing is rigidity in your tool post. It's an absolute necessity in your work. Try to park as close as you can to your chuck. That really can help a lot. And making sure your tool post, your gibs are tight, and things like that on your carriage and cross feed, so you don't have any play in anything. So I hope that answers some of the questions. Anyway, thanks for watching, you guys. Enjoy.